Hi, I'm Becky Ambrositis. I'm the sales manager for Globus Metal Powders.
My name's Adam Hunt. I'm the technical manager at Globus Metal Powders.
I'm Dan Frith and I'm the manufacturing and engineering manager.
Hello, I'm Andrew Lane. I'm general manager at Globus Metal Powders.
Globus Metal Powders started as a project within a steel organisation to investigate how additive manufacturing would benefit the business. After a few years of looking into and exploring additive manufacturing, it was established that that was an avenue that we needed to be involved with. And we then got support from the Tees Valley Combined Authority. They helped us with a grant and a loan to set up the plant here in Teesside, which is where we manufacture all of the metal powders that we produce, whether it be nickels, whether it be steels. However, our core is developing and designing metal powders for additive manufacturing as well as hipping.
So as a bespoke powder producer, we can produce a range of alloy types to very tight specifications. Something that we've worked on recently is the production of a bespoke high-entropy alloy for one of our customers. This offers a great combination of strength, ductility and weight. Something else that we've worked on recently is production of reduced activation steels for use in new generation of fusion reactors. One of these grades was urethane 97, which has very low levels of residuals, which are needed to stop the material becoming irradiated during neutron exposure. And finally, we've worked on a printable version of Inconel 939, which is not possible with the wrought specification. This concept could be applied to other alloys which are previously thought unprintable.
We offer a core range of printable powders for additive, 718, 625, M300, 316L are well proven. We also make Alloy X, and a recent exciting addition is a printable Inconel 939. We've produced full spec urethane 97, low activation steel for nuclear, high entropy alloys for novel applications, and also powders that are bespoke to customers' requirements. Our powders are suited to aerospace and space for turbine components and rocket nozzles, industrial gas turbines, oil and gas for valve trims and other complex shaped components. In motorsport, powders have been used in heat exchangers and exhaust manifolds, and in nuclear, where low activation steels are required to support the next generation of reactors.
Well, we've been members of UK since 2022. We benefit from membership through referrals that we get, industry insights, and interesting technical conversations. Well, UK has helped us develop our business. It's an extremely fragmented market with lots of different actors in it. And we find that UK helps us develop those relationships, understand who the decision makers are, and where we are able to develop our business. Well, I'm relatively new to this industry. I've come from outside of metal powders and AM printing. And so as an outsider looking in and on a fairly steep learning curve within the industry, I think there's a few fundamentals that need to be resolved for this market to really flourish and grow. The first thing I've observed is the cost of AM machines. The cost of these machines is just prohibitive for a lot of manufacturers, and the price points need to fundamentally drop to allow better access for more manufacturers to use this technology. If you draw a parallel to what's happened on plastic AM machines, you can now buy a plastic AM machine off Amazon for a few £100s. Now, I'm not saying that the price of metal AM machines is going to get to the same level, but a fundamental drop is going to make the technology far more accessible, and then the market will develop and become far more sustainable in the medium to long term. I think the second thing that I've observed is that at the outset of the metals printing market, there was an assumption that you could take a wrought material and atomize it and print it, and you would get the same performance out of the component that was manufactured from wrought and machined. I think there's been far too many examples where this just hasn't been the case, and I think OEMs, printer manufacturers and powder manufacturers must work together to modify existing alloys within their specifications to make them more suitable for AM printing, or to develop entirely new alloys suitable for this market. And I think the third thing that I've observed is the management of waste streams. There is a lot of waste powder as a result of processes, specifically laser powder bed fusion, and powder manufacturers, distributors and users of powder need to take their environmental responsibility very seriously and engage in the circular economy to make sure those powders are reintegrated into the supply chain, and those powders can either be re-qualified, re-certified, or reincorporated into the manufacturing process to make new powders.